Hey everyone, I'm Aidan. I work at Snowfork, and we're busy building a trustless bridge between Polkadot and Ethereum. And so in this talk, I'm going to talk a little bit about Polkadot's purpose, how bridges and interoperability fit into that, and what bridging means in the Polkadot context, and how our bridges is trying to be different and trying to solve some of the problems that exist in the space today. Cool. So what is Snowbridge? Snowbridge is a trustless bridge between Polkadot and Ethereum, and it involves two-way light clients. What that means is we have a light client running on-chain within Polkadot and within Ethereum, such that the chains can actually read each other directly, fully on-chain. It's fully permissionless, so anyone can participate, anyone can use it. It doesn't depend on any kind of third-party relayers or services, and it's governance minimized. And so what that means is, in order for the parachain and the bridge to get upgraded, governance has like minimal control. Most governance is deferred to Polkadot itself, and so we don't introduce any kind of governance vectors that can break the bridge into the system. Cool. So today I'm going to talk. This is like a quick overview of what I'm going to talk about. First, about like Polkadot's purpose and the implications of that purpose for how we should think about bridges in the Polkadot context. Thinking about how you compose trust models with bridges, and what it means for everything to be permissionless and on-chain. And then I'll talk a little bit how like Kusama is currently, the economic engine that powers Kusama is currently being compromised because of the existing bridges that exist there. And lastly, talk about Snowbridge. So Polkadot's value proposition is to sell security. So what I mean by that, Polkadot's a lot of things. It's a community. It's an ecosystem of parachains. It's Substrate and all the tooling and the programming languages and libraries around that. But what like Polkadot is really about, and the reason we have a blockchain and a token, is Polkadot being a relay chain that can sell security to other parachains. And so the purpose of parachains connecting to Polkadot and using it directly, rather than just using substrates or using the libraries and technologies, is that they're getting extra security from Polkadot when they connect to it. And so by registering your parachain on Polkadot and using it, you're getting that security. But if you go to the next slide, if we look at the state of things today, nobody's really buying this security. And so what I mean by this, so of course, a lot of parachains have been connected to Kusama and Polkadot. They have slots. They have paid for those slots. But what are they really buying with those slots? Based on the state of how things are today, it's not really security. And the reason for that we can get into is because one of the cruxes of security is around how trust is composed. So in like a distributed system, when you have multiple components and pieces, all of them need to be secure in order for the system as a whole to be secure. And so if any kind of pieces along that system are not secured properly, essentially the security is lost. And security has this interesting property most of the time, which if you go to the next slide, I'll talk about, where you're often only as secure as your weakest link. So when you're thinking about security in a distributed system, look at these two images, and you see on the left, we've got links in a chain with a little paperclip in the middle, which is like a weak link. And so in the left design, most of the security degrades, because if someone can cut and break the paperclip, they can break the security of the whole system. And so even though all the other chains, links in the chain are like strong and made of steel, if there's one weak link, the whole security of the system actually degrades to the chain. But if you look on the right side, you can see there's like two clips that are clipped onto the hook, and you've got backup security. And there, actually, you've got, if one of the points of security breaks, you've got this other backup that still keeps you secure. And there's trade-offs on each. On the left side, you're risking, like, if your security is being attacked, the attacker only needs to break the weakest part of the link, and then they can break in. But on the right side, especially in the context of a bridge, there's also a trade-off, because in order, say in the context of a bridge where you want to move assets from one chain to another, if there's 2 points of security and 2 points of verification, then it means there's 2 things you need to keep running correctly. And if one of them breaks, say, by mistake or goes down, then the system also becomes potentially insecure, and you run a risk of low availability of the system going down. And so there's trade-offs in how you compose trust and different ways to compose trust. And so yeah, today, with the current like Polkadot ecosystem and the parachains and bridges, most of the designs fit into the first case, and so I'm going to kind of dig into that and talk more about that. And so specifically in the context of bridges today, bridges, obviously we've seen a lot of bridge hacks and issues with bridges in the ecosystem as a whole. And if we look at the bridges that are currently active on Kusama, and Polkadot today, they range from things like multi-sig bridges, which have their own security trade-offs, to optimistic bridges, to a few other kinds of designs. So maybe we can go to the next slide. So today we've had Kusama running for a few months already. It's got a growing ecosystem, and it's kind of, you could say it's live. It's got decent liquidity coming in. But if you look at the actual state of things, the kind of Kusama DeFi ecosystem today is not actually secured by Kusama. And the reason for that is like most of the liquidity in Kusama's DeFi ecosystem today comes from Ethereum. It's stuff that's been bridged over through existing bridges. And because none of the bridges today really absorb Kusama's security, what that means is the whole Kusama DeFi ecosystem is secured by these bridge security models, for example, multi-sig bridges, rather than by Kusama itself. And so this is like problematic in multiple ways. The one is, of course, because the security degrades to the security of the bridges. And so it means the ecosystem has a different security profile, different kinds of risks to what people expect from like a Kusama or Polkadot ecosystem. But even more fundamentally, these bridges disrupt Polkadot and Kusama's like economic model. So when we think about what's the purpose of the core relay chain of Polkadot and Kusama and the DOT token or the KSM token, it's to provide security. And so if like this DeFi ecosystem is emerging and it's getting security from somewhere else, like the multi-sig bridges or other designs, even if those designs are secure and reliable and they're run by good people, there's still this risk that it disrupts the economic engine of Polkadot and Kusama. And so if you look at like DeFi protocols, currently they are having to pay like large amounts of rent for parachain slots every year. And so long term, if they don't end up actually using the security because they're getting enough security from their bridges, then it may not make sense for them to still want to support the economic engine long term. And it could make sense for them, for example, to eject and become an independent chain rather than be part of Kusama or part of Polkadot. And so it's not just a security risk that the existing interoperability and existing bridges bring to the ecosystem. It's also a risk on like the economic engine that powers the relay chain. And so back to Snowbridge. I talked a little bit in the beginning about how it works. And so understanding how Snowbridge is different and why it doesn't have these negative side effects, back to the point of like two-way light clients and running on chain, how this works in practice is the bridge itself runs entirely through on-chain code, and that on-chain code is running within Polkadot's virtual machine, and it is secured by Polkadot. And anyone can use the bridge without permission. If I want to send tokens like of my own from Ethereum to Polkadot or back, I can just send messages to Ethereum and Polkadot like normal transactions without depending on any third party. And so there's no like additional source of security or additional kind of gatekeeping to the bridge, which means that there's no like weak link in the chain that introduce either a security risk. It also means that the like security of the bridge comes from Polkadot because the security comes from the on-chain code and logic that's running within Polkadot's engine, and that it's being secured by Polkadot's consensus. And so essentially what that means is we don't have to deal with some of these side effects of the other bridges. And so longer term, these fundamental risks that the other bridges may have to the ecosystem are not present. And so again, to rehash, we preserve Polkadot's censorship resistance because there's no additional third party. The fraud is prevented because there's just on-chain logic that prevents fraudulent messages from being passed through. And recovery and upgrades and upgradability is governance minimized, and it's driven by the core Polkadot token. So one thing to keep in mind is a lot of systems, even though they may be secure in their logic and implementation, often they introduce governance that then brings in a risk of insecurity because there's some alternate token that can be used to upgrade the chain. And that introduces a different security risk because now the chain is being controlled, again, by something that is not Polkadot. And so with Snowbridge, it's governance minimized. And so recovery and upgrades will be driven by native Polkadot consensus and token. Cool. This is kind of the end of presentation. If you're interested, get in touch. You can check out our Twitter and Discord or a website, which we've just put up. And so what's the status of the project? We've been running for a few years now. There's a few pieces that we're waiting on Polkadot to deploy as upgrades in order for our bridge to run. And so we're hoping those will get deployed in the coming months. Additionally, because our bridge is based on-chain light clients, we follow consensus. And so you may be aware that Ethereum is moving to proof of stake. It's upgrading. And so with that, we've also been developing a proof of stake light client that allows us to follow Ethereum's proof of stake network. And so I'm going to go into and give a quick demo of that. So cool. So we've got a few minutes. So what I'm going to demo today is specifically the new proof of stake live client that we've been working on. And so to start off, you can see here's my terminal. I've got 3 tabs. Here I'm running our parachains in a test stack. In the middle, you can see logs. And so I started running this at the beginning of the talk. It's been running for a few minutes now. And if we run through the logs, you'll see what we're doing here is we're following the Ethereum beacon chain. And so this is currently running against the live real-world Ethereum 2.0 proof of stake testnet. And you can see new slots, which is kind of a form similar to blocks in Ethereum's proof of stake, are being produced. And this is code being outputted by a parachain live client, which is following the Ethereum merged chain. Here I've also got logs of a relayer that I'm running. Of course, anyone can run the relayer. And so here you'll see, here's an example where the relayer synced slot 791392 from the live Ethereum chain into the parachain. And how the bridge works is it also goes back and backfills the actual execution state of Ethereum. So how Ethereum is going to work post-merge is the proof of stake chain is producing block headers, but it also includes a reference to Ethereum's one original chain and original state, which has all the smart contracts and all the applications that you're probably familiar with. And so we go in and we backfill the execution headers, which you'll see happening here. And so as an example, we can see here, like most recently, slot 791392 was added. And so here I'm going to query this. This is querying a real Ethereum client. And so you can see here's a block header that is coming from the Ethereum client. And if we go look at our parachain, I'm going to go to Polkadot.js, which is currently looking at my parachain. And OK, let me refresh. It's freezing. OK, of course, Chrome crashes in the middle of the demo, but it looks like it's reloading. Here we go. OK, some problem with Chrome, but I've got a video as a backup, and so I'll show this. And so what happens is you can see this is the Explorer for the parachain that's currently running. If you go to the chain state, you can go and query the Ethereum beacon client and query the execution headers. You'll see here in this demo, the logs are being tailed. And the relayer has just been run. It's fetching syncs and fetching the sync committee from the Ethereum chain. And these are logs from yesterday when we took this recording. And you can see some Ethereum slots from yesterday were processed. This one is 785056. And so you can go here and see we're querying for the latest finalized header in the parachain. And that header has been included in our parachain and being followed. Similarly, I think next you'll see the actual headers being queried. And there we go. And you can see there's this header with the parent root, the state root, the body root. This is Merkle proof data coming from Ethereum that's now been verified and included in our parachain. And that can be used to verify any state in Ethereum post-merge. Here, we're going to query the sync committee. And you can see here are the public keys of the Ethereum proof of stake sync committee from the Ethereum testnet. And that's the block root of the block from when this was run. I'm going to skip ahead. And you can see here the last thing is the execution header. And so the execution header is where the actual smart contract data and state from Ethereum lives. And that's also verified and included within our parachain. And if you go and look at the actual block explorer from Ethereum's proof of stake, you'll see that the execution header there matches the one that's in our parachain. And so yeah, that's the end of the demo. I'll check quickly to see if this one is working now. Oh yeah, it looks like it. But no, Polkadot.js. Here, this is the live one that's running on my chain. You can see I can query the latest finalized header. This is further ahead, 791328. And latest finalized beacon headers. and the rest that you saw in the video. So yeah, that's the demo. I'm not sure how much time is left, but if there is any questions or there's time, happy to take one or two. But yeah, I can't see the time left now. But yeah, any questions, feel free to shoot.
For the bridge.
So the bridge is already built with the messaging protocol there. And what I demoed now is just the light client, but on top of the light client is the messaging protocol, which supports arbitrary applications. Currently, we've got some example applications that are running on Rococo for our old Ethereum 1 bridge, which is being deprecated as we're moving to Ethereum 2. And if you go and look on our, if you go back to the slides with the last slide that points to our Twitter and Discord, if you follow links there, you'll be able to see links to the code where there's already some example applications that are built on top of the messaging protocol. Cool. Thanks, everyone. And feel free to reach out if anything of this interests you.